Welcome to a lesson with Dr. Powell. Let's take a look at another function that we want to graph by using derivative information. X equals 0, x natural log x greater than 0. Okay, so let's take a look at this. Now, in order to do this, you think, well, this is kind of a piecewise function. Why don't we look at the derivative away from the edge here at 0? In fact, natural log itself isn't really defined at 0, so we're kind of appending a point on. Let's look at the derivative away when we think about the derivative. So when we do that, we end up getting, using the product rule, derivative of x is just 1, so natural log x plus, and then we have x times 1 over x, which is just 1. So we end up getting, okay, because we get x times 1 over x, right. So this is the first derivative right here. And that's going to be, we calculated it for x is greater than 0. Okay. And then let's take a look at maybe the second derivative as well. That's just going to be 1 over x, at least for when x is greater than 0. All right. Now, it's interesting to see kind of what's happening here. Maybe the first question we should ask is this function continuous or not? I mean, you know, this point seems kind of funny right here. So let's kind of think about that for a minute. What is the limit as x approaches 0 from the right side of x times natural log of x, which we could rewrite the following way. Use L'Hopital's rule, because we get infinity over negative infinity over positive infinity. So 1 over x and negative 1 over x squared. And we can rewrite this after we take derivatives by multiplying top and bottom by x squared, end up getting negative x when we do so. As it goes to 0, that actually goes to 0. Interesting. So this function, as we head towards 0, should actually connect with this point here and be a closed-in circle. Okay, just a little note there on that. Okay, now let's take a look at the first derivative information and see what we can glean from that. So on the first derivative, the only domain issue is kind of at the end point here. So let's kind of go in the interior, and the only other thing that could happen is equaling 0. So let's see where that's equal to 0. This is equal to 0 precisely when the natural log x is equal to negative 1, which happens at e to the negative 1. So or 1 over e. Okay, so let's just take a look at that, 1 over e, and think about this. Now, natural log x itself is an increasing function, and you just shifted it up 1, so really this derivative is going from negative to positive. And so we can think decreasing and then increasing. Decrease, increase. So it looks like we have a minimum, actually. If I did that right, yes. Okay, so we get a minimum here, right there. All right. So we know we have a minimum at negative 1 over e, and then we got that information from the first derivative. Now the second derivative, notice there's no really domain issues as long as we're away from 0, and there's no places where it could be 0, so it's always going to be the same sign. In fact, it's always positive. We're always concave up. Okay, and notice this is also a flattening here. This gives us a good indication of how the graph is going to look. Graph is going to start at 0, 0, as we've indicated, and it's going to be continuous at that point. But we also know we're concave up, and we have a minimum at 1 over e, comma, and then we can plug 1 over e into this function. In fact, we can do so. We would end up getting a negative 1 over e. We compute that out, and then it would be concave, and then it's always concave up, minimum. It becomes a minimum, and it just grows from there. In fact, you can notice that this function really gets large over time, so it's just going to go up from there. but kind of has an interesting start. And we notice that this right here is a global minimum. This is a local maximum. It's an endpoint. And there is no global maximum. It just keeps on going up forever. In fact, especially if you take a limit of this thing as x goes to infinity, you'd see that just keeps going up. Thanks for watching.